Hello, and welcome to the Smiths Interconnect webinar. My name is Katie, and I will be your Global Spec moderator. Now I'd like to introduce today's presenters. With us today is James Lucas. James is a product line manager of space fiber optics at Smiths Interconnect. Also with us today, we have John Lundberg. John is a product line manager of defense and aerospace fiber optics at Smiths Interconnect. To read more about either of the presenters today, please look at the speaker bio window right next to that main presentation window. Now I'd like to go over today's key learning objectives. So today we're going to discover how fiber optic connectivity provides significant advantages in bandwidth, distance, weight, and EMI. We're going to find out how Smiths Interconnect modules provide a very low SWAP, which is size, weight, and power solution for the toughest environments, while also enabling ease of assembly and maintainability. We will discuss how Smiths Interconnect has shipped more than 100,000 active fiber optic modules for the past 15 years for midboard and backplane applications for the mil-aero and space markets. Then at the very end, we will have an open discussion and take a couple questions from our audience. So everybody, welcome to today's event. I'm going to pass things along to John and James to get this webinar started. So gentlemen, go right ahead.
All right, thank you, Katie. This is John Lundberg. I'm the PLM for the defense and aerospace markets, and welcome and thank you for attending and listening today. It's our sincere hope that you see something interesting and that we can maybe support you on a project at some point. So I just want to cover the agenda up front. First, we're just going to have a quick slide on the company profile, a little bit of the history and what we do. Secondly, we'll talk about markets and applications briefly, although the pictures on the right are probably a spoiler for that. And then the bulk of our presentation is going to cover the highlights and features of our products, as well as details of the product families themselves. And then, as Katie mentioned, at the end, we'll have some time for Q&A, hopefully, and we'll try to answer your questions live. But if we don't get to your question here, we will follow up with you offline and initiate the conversation that way. So with that, let's begin. So the fiber optic transceiver business unit at Smiths Interconnect started off over 20 years ago as Reflex Photonics. It was founded outside of Montreal, Canada, and it was acquired by Smiths in November of 2019. We have shipped in that time about a little bit over 100,000 fiber optic transceiver modules into the mil-aero and space markets. So the facility you see there, again, it's outside of Montreal. It's pretty much everything is self-contained in there: operations, engineering, testing. The only things we don't do in-house are PCB assembly and also certain environmental tests, but everything else happens in that building, so it's very integrated. All right, and turning to the markets we address, the defense market, first of all, it's been our bread and butter for a long time. What that means is our parts are purpose-built for these rugged, nasty environments. We are not in the commercial space, so we've been addressing this market for a long time. Doing transceivers for these markets means minimizing something called SWAP. So if you're not familiar with the acronym, it stands for size, weight, and power, especially in airborne applications. It's especially critical. So we'll be talking about SWAP in some future slides. And our parts, of course, given the markets we serve, are inherently high reliability with a long mission life. And in terms of some of the specific applications that we can address, they're listed below. Those are just a few, but in general, any place where you need to move very large amounts of data, between your subsystems within be it an aircraft or a naval or a ground system, our transceivers can find a home. And when I say very large amounts of data, we're talking tens or hundreds of gigabits per second. And with that, I will turn it over to Jim Lucas.
Thank you, John. And hello, this is Jim Lucas. I am the product line manager for the Spaceable products. So Smiths has leveraged our ruggedized, lightable transceiver platform and extended it for applications in space by developing radiation-resistant Spaceable family. Now, the Spaceable products are used in high reliability, long mission life applications that have service lives of greater than 20 years. And at Smiths, we've performed extensive qualification on these modules to evaluate the reliability for space applications. And some of these examples are radiation is performed on the module at low energy and high energy radiation levels, mechanical integrity testing, shock, vibration, thermal vac, environmental tests such as outgassing, and also life testing. And I'll go into more detail on the different qualification standards and testing in a later slide in the presentation. What I would like to emphasize here is Smiths has spaceable parts in flight today that provide an optical backbone for very high throughput communication satellites. What I'd like to do now sorry about that. So what I'd like to do now is take a moment to talk about the advantages of fiber over copper. Now, there are several design considerations where optical fiber is the clear choice, and they are weight, size, and EMI. And if you take a look at this, the slide that I'm showing here, if you compare 12 coaxial differential pairs to 12 fibers, and what I'm using here are typical values for the weight of copper and fiber. So for the twin X, I'm using 536 grams per meter, and for the fiber, 12 grams per meter. And if you consider longer link distances and double the bidirectional full duplex, copper cabling piles on the weight very, very quickly. So comparing that, comparing the coax or twin X to a 12 fiber cable, there's more than 87% weight reduction. And this is a significant and also significant size reduction. As far as link length, for copper to achieve an attenuation of less than 12 dB, the maximum length is typically around 5 meters. And for fiber, loss is negligible up to 70 meters. And also with fiber, you can supply a high data rate such as support high data rates such as 25 gigabits per second. So to sum it up, the advantage of fiber, smaller size and weight, copper cabling piles on the weight quickly at 22 grams per meter. Fiber links are capable of higher data rates, and also there's the immunity to EMI, which means no shielding required with fiber. Next, I would like to talk a little bit about the electrical and optical interfaces that Smiths offer. On the left-hand side, you'll see a land grid array interposer. And this provides electrical contact and mounting between the optical transceiver module and the PCB. And from the slide, you can see the stack up of the optical transceiver with the interposer. The compression-mounted interposer is positioned between the transceiver module and directly to the PCB. The transceiver is then screwed to the PCB, eliminating the need to solder or use of a socket on the PCB. This provides ease of use during system development with no need to solder. And also, use of interposers help reduce parasitic capacitance and inductance for high-speed performance. So, use of an interposer, it's a very rugged yet easy method for assembly and removal. What I'd like to talk about next is the micro clip, what we're showing on the right hand of the slide. Now, the Smiths optical transceiver assembly consists of an MT ferrule, which couples light in and out of the module. The micro clip is used to mate a multi-mode fiber ribbon to the MT ferrule. Using MT ferrule eliminates fiber pigtails and allows flexibility of routing after the board is assembled. In addition, if there's a problem with the optical fiber, flexibility to replace the cable is not entirely modular because it is pigtailed. Smiths has performed mechanical vibration testing using the microclip and has exceeded 80 grams RMS, which is much higher than the typical satellite launch conditions. In addition to the MT microclip, an MPO version of the microclip is available for lightable product line. Back to you, John.
All right, thanks, Jim. So just want to talk in a little more detail about our transceiver modules and how they fit into our market. So I mentioned swap, size, weight, and power up front, and I want to dive into that a little bit. So our parts are very low profile. I mean, besides not taking up space, the small size has the added benefit of making these modules very vibration resistant and tolerant, and shock as well. So specifically our parts, when mounted with the interposer that Jim just talked about, they're about 5.5 millimeters off the surface of the board that you're mounting it on. And in terms of width, our transceivers are all about 14 millimeters wide. The length can vary a little bit by a couple of millimeters depending on which particular module you're using, but yeah, these are roughly the dimensions of it. So they're very small, and the footprint is what you see. There's no, mounting brackets or hardware on the board or anything required. It's simply screwed on the board through the transceiver and the interposer. So again, just to reiterate the point, because we have been playing in the defense market exclusively for a while, it is, these parts are designed and constructed for these high reliability, harsh vibration and temperature requirements. Minus 40 to plus 85 is the standard military temperature range, that being case temperature. And we also have radiation testing for our spaceable products, which Jim will tell you about a little later. And then lastly, we also have quality controlled assembly and test processes in place, and these can vary in some of the details from program to program. So I want to take a minute here to talk about data rates and also some terminology up front. So you may hear us interchangeably say either 25 or 28 gigabits per second for our 28 gig product. They're one and the same. The physical line rate of our transceivers, at least the 28 gig family, is 28.05 gigabits per second. 25 gigabits per second comes from the Ethernet world. It refers to the fact that 100 gigabit Ethernet has some FEC encoding overhead associated with it. So the effective data rate is 25 gigabits per second. But if you hear us say 25 or 28 gigabits, that's why. And also for any of you unfamiliar with the fiber transceiver business, I just want to talk about some terminology, lanes and channels. So when we talk about channels, that's unidirectional or half duplex. It just means the light is traveling from one point to another, and that's implemented in a single fiber. When we talk about lanes or full duplex, that means bidirectional. So the traffic is going in both directions, and that is physically implemented in our transceivers with two fibers. So with all that said, the three configurations, or I should say four configurations for our modules are as follows. First, in the middle there on the upper side is the 4TRX. So that's 4 lanes of receive and transmit full duplex, and that occupies 8 fibers. So you see the 4 transmit fibers up top, the 4 receive fibers on the bottom, and there's 4 fibers unused in the middle. So the interface to our modules, as Jim mentioned earlier, is a 12-fiber ribbon cable. So the 4TRX uses 8 of those 12 fibers. We also have a 12TRX product. That's 12 channels of transmit and 12 channels of receive to give you 12 lanes, full duplex. And of course, that uses a 24-fiber ribbon cable. And then lastly, our last two products are the unidirectional half duplex, the 12-channel transmitter, and the 12-channel receiver. So these 4 configurations are what we offer in our families. In terms of data rates, so we offer 10 gigabits or 25/28 gigabits per second per lane or per channel. And on the bottom left there, you can see it tabulated what each of our modules can offer you in terms of data throughput. All right, so now we're going to talk about our three product families that we're highlighting today. The first one is the lightable. This is our midboard, and in the case of our MPO variant, a front panel solution for the aerospace and defense markets. All right, so on the left is our lightable LM family. This is an older family that's been running for quite a while, for several years. We sell a lot of these. These are 10 gigabit only per channel, and we only offer these with either surface mount or a pluggable socket. So these are, like I said, it's an older family, but they're still going strong, and there's a lot of people still buying these. So we do have that attachment option, that board attachment option, for those who are interested in either solder down or using a pluggable socket. And more recently, we've rolled out the lightable LL family. So these are available in both 10 gig and 28 gig. And these use the interposer that Jim talked about earlier. The interposer attachment method is the preferred method for most designs happening nowadays. So that seems to be preferred for the reasons that Jim laid out earlier. And key advantages, again, it's all about, again, for these markets, be it defense, space, aerospace, it's minimization of swap, small size, low power consumption, and again, rugged. It has to work in the environment, and it has to be fully qualified. These parts are sealed for protection from the outside environment. And our suite of qualification tests are shown below. So it's all the usual suspects for MIL standard environmental testing. You can see there. I won't read them out, but they're there for your reference. And feel free to follow up with us after the webinar. All right, so lightable was our sort of our workhorse midboard solution. So now we're going to talk about a more recent family that we've rolled out. Is called Light Connects. And this was intended for active optical backplanes for open VPX systems. So this concept was born in the VITA 66.5 committee for defining an active optical backplane. So first, let's take a step back and just kind of look at the history a little bit. Earlier VITA standards like VITA 66.1 would define a passive optical backplane. So the typical scenario is you would have your transceiver midboard right near your ASIC, and that ASIC could be a very large FPGA, it could be a multi-core processor, it could be a multi-port gigabit Ethernet switch or something like that. And people would typically place their transceivers really close to the ASIC, and then they would run a fiber to the backplane connector on the plug-in card, and that in turn would connect to the connector on the backplane side. And so it was an entirely passive connection. The spring to maintain the mating force was on the plug-in side on the left there. And so what VITA 66.5 wanted to do was to move the transceiver from the midboard and integrate it into the backplane connector itself. So now you've taken your transceiver off the midboard, you've integrated it with a backplane connector shroud, and now we've also moved the spring that maintains the mating force to the backplane side. So the spring now resides in what we call the insert connector. So that's the basic concept behind VITA 66.5. And the backplane connector has some float to it. So it floats about 0.5 millimeter in every direction to maintain alignment, to guarantee alignment of the fiber end faces with each other on both the plug-in and the backplane sides. All right, so what are the benefits of VITA 66.5 and also Light Connects? The main one was by taking the transceiver off the midboard and integrating it with the backplane connector, you've now freed up board area to be able to do other things. So you can put additional memory there or whatever other functions you see fit. So it's saving board space. And looking at the backplane side, it also maximizes bandwidth port density. So if you're talking about gigabits per second per square centimeter, this standard really maximizes that. In a VITA half width, you can get 700 gigabits per second full duplex, bidirectional in other words. Or if you look at the picture on the right there, that represents a VITA full width, roughly 30 millimeters wide, you can get 1.4 terabits per second bidirectional in that space. And some of the other benefits that it brings is simplified assembly and maintenance. So looking on the backplane side, the backplane cable disattaches easily from the backplane connector. So if you have to replace your backplane cable for any reason, that's easily done. You don't have to take apart your backplane. And you'll see that in more detail pretty soon. The interposer for the electrical connection on the plug-in module, or the transceiver, I should say. That has all the benefits that Jim talked about earlier. It makes it really easy to assemble and perform maintenance on your board. And lastly, using the plug-in module as opposed to the midboard with the jumper cable, it eliminates the need for that cable. The cable is a possible snag point. The plug-in cards are blind mate, and the cables represent, not just an extra component on your BOM, but also a possible maintenance issue. All right, so we're just going to step through the components of the LightConnect system and the Vita65 interconnect. So the plug-in card is illustrated on the top, and your backplane is represented on the bottom. And you can see two pairs of the LightConnect modules on both the plug-in card and the backplane side, shown here. On the plug-in card, the transceiver modules with the shroud are called plug-in modules, and on the backplane side, those connectors are referred to as inserts. In the particular model shown here, we'll talk about the different styles later, but Style D is shown, and Style D provides accommodation for passive connection points. So if you do happen to still have midboard transceivers, they can connect through the shroud on the plug-in module. And lastly, the shell. That's the piece that holds the inserts onto the backplane. So now let's try to illustrate this a little more graphically. So this is an exploded video, and what you'll see is two pairs of LightConnect modules, the two inserts on the backplane side, which are visible here, and then the two plug-in modules on the plug-in card side. And you'll see them lift off the board, so I'll just run the video. And now you can see how the plug-in module is attached to the board via the interposers. You can see those interposer boards underneath. And now the inserts are coming apart. And you'll see the springs on the backplane cables for maintaining the mating pressure for the MT. So I mentioned earlier how the backplane cable easily disassembles from the inserts, so you can see that there. And again, I'll just let this run a second time to kind of drive it home. The two plug-in modules are different. They're style C and D. We'll talk about that in a little bit. And you can see how the midboard jumper cable disattaches as well. All right, so let's take more of a close-up now of the LightConnect's plug-in and insert modules. Start at the top. Again, the fiber interfaces we use, they're either 12 fibers or 24 fibers of what's called an MT fiber interface. So most of our modules use the 1x12. They only require 12 fibers or 8. But for the 12 TRX device, which again is 12 lanes of receive and transmit, the 24 fiber MT is used. So that has 2 rows of 12 fibers. Hopefully you can see those 2 rows on your screen there. And then to take a closer look at the plug-in module, we're showing style D here because it's just the most complete one. But a LightConnect module is basically just a lightable module with a backplane connector shroud attached to it. So you can see the transceiver sticking out the back there. And its fiber interface occupies what's called the A position on the shroud. And then, as I mentioned earlier, Style D offers 2 connection points for any midboard transceivers you have. So those passive connection points occupy the B and C positions on the transceiver. One other feature I'll point out is the slot. So if you see it underneath there, the slot is for the guide tab. So that's what aligns the plug-in module with the insert module and makes sure that ultimately the fiber end faces are making contact, or making a solid connection with each other. So with that, these are the 3 styles of plug-in modules that we offer. Style A is an older module that we've had for a couple of years. The one thing that distinguishes that from our newer ones is that the guide tab slot is above the fiber interface. So with the newer modules, style C and D, the guide tab was moved to be underneath the fiber interface. So Style C is just the transceiver module, and again, Style D offers the transceiver module plus 2 additional connection points for midboard transceivers. And so every plug-in module has the corresponding insert module on the backplane side, and you can see these below. So guide tab slots on the plugins, and the guide tabs are on the insert modules. One thing I'll point out is Style D also has a guide tab on the top of its module. So because of the upper connectors, provides additional alignment. All right, I'll turn it back over to Jim for the Spaceable family.
Thank you, John. So I'd like to take a few minutes to talk about the Spaceable product offering. And these are midboard solutions, operating at both 10 and 28 gig. And, I mentioned previously how Smiths has leveraged our, ruggedized, lightable transceiver platform, and extended it for space. And, we've already discussed, some of the key advantages of the Smiths, transceiver product offering, size, data rates, full duplex, half duplex configurations. So, what I'd like to discuss now is, what's key for space applications is reliability and long life. And, what you see on the left-hand side of the slide are examples of different space qualification standards that have been established by NASA, ESA, and MIL standards. And these are the standards that Smiths use to test against for space readiness of our transceiver products. And, within Smiths, we have performed qualification testing to evaluate the reliability of our Spaceable products. For the 10 gig Spaceable products, we have what's called the Space Test Program. And also for the 28 gig, we have what we refer to internally as the Space Test Program 2. And, as a result of these programs, we have qualification reports available, that support our space readiness. Now, in certain cases, customers will have specific qualification requirements, based on a known mission profile. And in such cases, we have performed customer-specific testing. And in some of those instances, we have exceeded the standards. And in other instances, we have far exceeded the qualification standards set by NASA, ESA, and the MIL standards. For the Spaceable product grades, we offer 2 types, the engineering models and the flight models. So the engineering models, they're supplied for ground evaluation, and the flight models are used for the mission. And so if you look on the furthest left-hand side column, it lists the details such as BOM, different processing steps and screening, visual inspection, electro-optical testing that's performed on the optical modules. What we do is discuss the differences between the engineering models and the flight models. And that's in the second and third column. And for the flight models, there is a burn-in that is performed on these devices. Engineering models, they are traceable to the manufacturing order. Flight models, these are traceable to components used in each module. And also for the flight models, each manufacturing lot uses a unique component supplier lot for the active components that are used. And then lastly, for the flight models, light acceptance testing is performed on the manufacturing lot for these devices. So lot acceptance testing, for flight models, LAT, as we refer to, is performed on each manufacturing lot. Yeah, and the purpose of the LAT is it's a reduced set of qualification tests on a sample size of the manufacturing lot to validate the quality of that particular manufacturing lot. Smith has standard lat threads that consist of life, environmental, mechanical shock and vibration, and radiation testing. These tests are based on established standards, and also the lats are performed by both Smiths internally, and we utilize third-party labs. And in certain instances, we can also support customer-specific lat requirements. So that kind of wraps it up for what I wanted to discuss about the spaceable products. Thank you. That concludes my part of the presentation, and I'd like to turn it back over to Katie.
All right, gentlemen, thank you both so much for a great presentation. So we are going to move into our Q&A section right now. So, gentlemen, let's move into our first question. Now, this person asked two questions. I'm going to kind of combine them into one for you. So first part is, which is the distance between each equipment that's allowed, and is it suitable for ATEX classified area?
Okay, I can field those. Yeah, I mean, assuming you have a good link without too much loss, you can get, for the 10 gigabit products, you can get 70 to 100 meters, and for the 28 gig products, it's more like 70 meters. So again, you just have to be using the proper fiber. There's another question in the chat asking which fiber type it was. So all our products here that we presented today use multi-mode fiber. So we use a 850 nanometer VCSEL, and the transmission medium is multi-mode fiber. With regard to ATEX, yeah, I mean, our parts have not been qualified for ATEX zones, but yeah, I mean, please contact your local Smith salesperson and follow up with us afterwards, and we can talk to you about it and what your exact requirements are.
Okay, great. Thank you so much for that answer. So moving on to our next question here. This person is asking, when we speak about connections, MT, clip, etc., is this relevant to SM, or both?
Yeah, that was the other question I was trying to answer at the same time. So yeah, again, everything you saw here today uses multi-mode fiber ribbon cables for the interface.
Okay, great. Thank you so much for that answer. All right, we have a lot of questions popping into our window here. This is great. Thank you all for your questions. As I mentioned, a lot of these may be answered following today's webinar. So if you don't hear your question being asked, do not worry. We will reach out to you following today. All right, so it looks like we're going to go to this one here. So gentlemen, how many spaceable modules have been put in space and what orbits?
Oh, sorry about that. I was muted. Yeah, thank you. So the orbits that our spaceable modules have been using typically are in geosynchronous. And, we do have addressed some LEO and MEO, but, the majority of the product is in geosynchronous orbit. As far as the quantity, I don't think that's something that we would typically answer.
Okay, thank you so much for that answer. All right, so next one here. All right, let's take one of these questions. So this person is asking, does Smith have any plans for data rates beyond 28G?
Hi, I'll take this one. Yeah, we do. So our, the industry is always moving onward and upward, and it's sort of an unwritten rule that the aerospace data market kind of follows the commercial data center market by several years, like maybe 7 or so. So the state of the art with the data center markets is moved into PAM4 modulation, and so the next step after 28 gig NRZ, which is a modulation scheme, is to move up to 56 gig PAM4. So yes, we're definitely keeping an eye on it, and we will be addressing that once the aerospace market starts making that move to that data rate. I also want to take a moment to go back and answer or re-answer a previous question. The link length, the maximum link length for 10 gigabit Ethernet is 300 meters. But that's just not something we ever see in an aircraft or any kind of military system. But yeah, if you look at the 10 gig Ethernet standards over, the appropriate multimode fiber, you can get 300 meters out of those.
All right, great. Thank you so much for that answer. So we do have time for a couple more questions today. Moving on to this next one here, gentlemen. Will there be a Space Connex product line?
Hi, yeah, I could answer that one. So, we do have the Light Connects product line, and we can certainly leverage, that platform for the Spaceable product. So if it's something that, a customer is interested in, we would love to discuss that with the customer. Thank you.
All right, great. Thank you so much for that answer. So I just want to point out a couple things to our attendees really quickly in the middle of our Q&A session here. In your attendee console, we have some resources that you can take with you today. They are just below the Q&A window. There is a resource list. There's a bunch of resources in the list. You can download them at any time today. So feel free to do that while we're taking some questions, just so that you don't miss out on grabbing that great content. Just to note, there's a couple questions in here about being able to access this webinar after it's over. We will not be sending the video itself out of the webinar, but you are able to come back and watch this webinar at any time during the next 90 days. We will have this on our site. It will be on demand, and we will be able to have anybody register and come back and watch it over that time. So you won't get the copy of the video, but you will be able to come back and watch this as many times as you would like during that 90 days. All right, so moving on to our next question here. Do you have any analog products like RF over fiber?
Yeah, so, we've developed, or we've done some engineering prototype here at Smith for RF over fiber, and we do have a product in development, that uses our ruggedized platform and to develop RF over fiber modules. If a particular, or if you are interested in, our development, we'd love to you contact us so we can discuss your specific needs, for RF over fiber. Thank you.
All right, thank you so much for that answer. So as I mentioned, we do have time for a couple more questions. Next one here. Can spaceable and lightable fiber optic transceivers electronically interface with 10 gigabase -KR4? If yes, has it been tested with that interface?
Yes, I'll take that one. Yeah, the short answer is yes. Our modules are protocol agnostic. They're just, they're strictly physical layer devices. So, yeah, I mean, that's the short answer is yes, and we'd love to follow up with you on more details of your application.
All right, fabulous. Thank you so much for that last answer. So we do have a handful of questions left in our queue. We are going to get most of these done following today's webinar. We are hitting that about 45-minute mark, so we're going to start to wrap things up right now. So thank you, everybody. If you have any other questions or comments, you are able to enter those into the Q&A window during the on-demand period that I just talked about. And as I mentioned, anybody's question that's still here that has not been answered, we will reach out to you following today's webinar. So, gentlemen, thank you so much for a great presentation today and for fielding some of our attendees' live questions. So, John and James, thank you both so much.
All right, thank you, Katie.
Thank you, Katie.
Thanks, everybody.
And thank everyone for being here.
Again, thank you all for taking time to attend this webinar event. Take care, and we will speak with all of you soon.